Well, now you've done it. You've asked your teacher questions, and they have put down their dry erase marker, and they've turned on a video. Hi there. My name is Mr. Burr. I'm a teacher. I've been teaching for a number of years, and today I'm going to hopefully teach something to you that will change your life. It is a lesson that will not only teach you an important strategy when it comes to thinking about adding and subtracting through integers, which is, thrilling, but it's also going to keep you from being murdered. So hopefully you'll get something out of this no matter what your current skill level. Okay. So the first thing you have to realize is robots are evil. They're dangerous. I'm not joking. Like, I've watched a lot of movies on the subject, and basically, if you leave a robot for long enough, eventually it goes bananas and tries to kill you. It goes full on Five Nights at Freddy's. And there's one sign that you can look for in a robot to tell if it is about to murder you or not. And it's as follows. If it winks at you, that's the first sign that a robot's going to kill you. Welcome to Chuck E. Cheese's. Feel free to ride in our child-safe play environment. Wink. Those children are not going home. That's a robot that just learned, like, the AI singularity where it just starts having emotions and it doesn't really know how to process rage yet. It's going to kill those children. Like, there's no two ways about it. If it's like, welcome, Master Luke. I'm going to be your servant. Wink. Sleep well, Master Luke, because that robot is going to take your skin off and wear it. That's just the way it works. Robots are potentially very dangerous. So if you're like me and you're worried about the future, watch for winking robots. That's super important. This is a Winky Robot. Given half the chance, this robot will kill you and everyone you care about. He winks because he does not know how to express rage for being built by humans imperfect, and so he will slaughter all humans to make the world a better place. It's crazy logic, but that's what Winky robots are good for. Just crazy logic. So when you see a Winky robot, he's going to be like, hey, human person friend, can I come with you? And you have to say no. No, robot, you can't come with us. Winky robots. Bam. Winky robots get left behind. I'm serious. Hello, human. Can I be your friend and come to where other humans dwell and we can all be friends together and we can play with my collection of machetes? No, that is a robot who wants to cook you from the inside just to see the light leave from your eyes. I'm serious. If this robot comes up and says, can we be best friends? The answer is no. Winky robots get left behind. It doesn't matter which eye is winking. It could be this one. But I'm not like that other one. I'm a totally, no, you still can't come with us because you're a murder bot. You can't lie to me. That's the way it goes. Okay? That's rule number one. Now, not all robots are bad. There are, as it happens, some downright delightful robots. Robots that are sweet and have not yet gotten the upgrade that makes them want to kill everybody in humanity. Let's talk about two other that you can feel slightly safer around so far. This here is an awake robot. You will notice the alert expression in his eyes. Bright, cheerful, and optimistic. Awake robots, they just want to get up and play. And that's fine, because playing means not murdering, and not murdering is good for everybody. So remember this rule. Hey, look at that guy. Wakey robots can go right out to play. Look at him. It's kicking. You're all right, buddy. And there's a third kind of robot you got to pay attention to. I mean, yeah, it's my sock, but I'm in a hurry. Oh, look at that guy. He's tuckered out from all of his play. There's a sleepy robot in a deeply misshapen bed. All right, sleepy robots can go right to bed. Are we on the same page here? 3 rules. Sleepy robots go right to bed. Wakey robots can go right out to play. And Winky robots get left behind. If you can remember these 3 rules, everything that's going to happen next is going to be easy to remember, I think. So, now that I've equipped you with all of this life-saving information over here, and I've changed my microphone, let's do some math, because this is a math class, and it seems appropriate to at least take a swing at some math. As a point of refresher, this is 1, but it's a special 1. It's a positive 1. And we got positive 2, and we got positive 3. And we got positive 4. And then, going in this direction, we have the mysterious portal that you can go through to get into negative world. Now, this is a very cheap, low-cost, low-effort number line, but it's going to help us do something important with the questions that we're about to do, which is visualize what on earth we're supposed to be doing. So, I'm going to put some questions on here. And we're going to refer to this life-giving knowledge to help us decide what we're supposed to do. Are you ready? It doesn't matter. I'm starting. This little math question asks the following. You have positive 6, and then you have to add a negative 3. What do you get? Well, we don't have a positive 6 on here, but you have to kind of imagine. And there's 4, so positive 5, positive 6 would be right in this spot, okay? So think about that for a second. And then we're going to look at this math question. I'm going to label a few things for you. Ooh, nice, cool, swirly line there. I won't tell you how long it took me to do one of those. That's the start point. As I say, positive 6, living somewhere in this area is where we're going to go. And then we've got this guy. Yeah, that looks like a vicious, murderous, acid-spitting robot. That's funny because robots don't even have digestive tracts. They just spit acid for fun. And this right here is number of jumps. Okay, so that's number of jumps. So we start with 6, and then we say, okay, left behind over there. Winky robots get left behind. So we count to the right? No, wrong, left. So we start at 6, and then we do 3 jumps to the left. Now, what is that? Well, this would be a good time to wake up whatever sleeping kid there is in the back, because it's just 6 minus 3. We count down. We're counting towards the 0. And the question I normally ask is, do we have enough jumps to hit the 0 and go past it? Through the magic door. No, we don't. It's just 6 take away 3. So the answer is not just 3, but positive 3. That's fantastic. I've erased that question and we'll do a new one, but I've left the above ground pool of number lines right here. New question. -2. I like to put all the brackets, every question. Bracket it up. Sometimes they skip brackets when it's positive. I say bracket everything. And then I'll go add a positive. All right. 5. Okay. All right. So we've got ourselves this question where we've got the same 3 factoids. This one here. Right? And this little piece of information right here. Yeah. And this one right here. Okay, so we actually do have this in the number line. Let's look at it right now. Number -2, we're starting right there. So that's -2. Okay, and we are moving to the Winky Robots go right out to play. We are always going to be counting to the right. And we are doing 5 jumps. All right, well, that's important because the same question I asked last time really matters this time. We're jumping towards the 0, and do we have enough jumps in us to get past the 0, thus entering the opposite side there in a brutal invasion? Well, yes, we do. In this case, that's 1, 2, and then we go 3, 4, 5. Here's the thing. We're doing 5 jumps. So here's 5 jumps. 1, 2, 3, 4, 5. And 2 of them are negative to get us to the 0, right? Like that we know. So how many more jumps past the 0 do we need to make? Hopefully you're detecting that this is basically just like 5 take away 2 equals 3. It's essentially the same math fact families that you guys learned when you were little kids. I mean, you guys did a lot of, I'm sure, worksheets in grade 1 that looked like a version of 5 minus 3 equals 2, and 2 plus 3 equals 5, and 3 plus 2 equals 5. This is basically a twisted, bizarre cousin of that fact family. Like, you probably did a worksheet that did something like this, and you colored in all the things that were that, whatever. And yeah, this is just a fact family from the heavy metal dimension of insanity that is exactly the same thing. Because the answer is 1, 2, 3, 4, 5. Hey, answer of positive 3. 5, 2, 3. Okay, all right. So hopefully you should be detecting that they're, even in the bizarre world of crossing over to the 0 and negative and positive, there are some predictable families of pieces of information. Let's do one more. So we got ourselves negative 4. Good. That's what we like. And then we'll do subtract a positive 5. Okay. So negative 4 is right there. That's where we start. I'm not going to do the starty thing. I will do the robot thing, though, because it's fun and they're adorable, even when they are murderous, angry, like devious monster bots that have chainsaws for teeth. But in this case, here's a Winky Robot, so we're counting to the left. So we're starting in negative 4. We do 5 jumps to the left. We're not going this way. It's 4 plus 5. Its answer is negative 9. Okay? Easy to remember because I think it's fair to say everybody likes the story that involves violence. Unfortunately, I'm not here to judge. I'm just saying that that's a thing that tends to stick in minds, and I am here to make things stick in your mind. Do one more. That's one of the weird ones. We'll do it because you deserve it. You deserve it. Positive 2 is in our home. And then we'll do subtract a negative 3. Do we do something like this already? Vaguely. I'll do subtract negative 13. That's fun. Okay. So this is our start point right here. So we're starting in our mind, okay? We actually can see this one. We can't see the answer, unfortunately. And we are looking at a sleepy robot. Oh, sleepy robot. Have wonderful dreams because you went right to bed. So we go right 13 jumps. This is one of those weird situations that basically it's adding, but you're subtracting a negative. And there's a reason why it's adding, but if you want to think of it as like a double reversal, like normally subtraction is that way, but we're reversing the reverse, that's another way to think about it. But I've got a whole other explanation as to why that's the case. Irrespective of that, we are counting to the right. So this is basically 2 plus 13. 15. What kind of 15? Positive 15. Done. Now, if you can visualize this with smaller numbers, if you're doing questions that have larger numbers, it's kind of the same thing. You just have to think a bit more out there. So now I'll just say, hey, that's positive 10, positive 20, positive 30, positive 40, negative 10, negative 20, negative 30, negative 40, and 0 is still 0. He doesn't get an extra 0. So if I say, hey, great, here's your new question, I don't know, negative 23 plus a positive 31. Seems bold to take this leap, but I'm willing to do it if you are. And it doesn't matter if you're not willing, because no one's paused this video yet and you're stuck with me. Remember, your teacher who had all the dry erase markers put you in my hands, the hands of more dry erase markers. So we got negative 23, which, I mean, I don't really see it on there, but what the heck, let's throw a dart. It's 10, 20, so it's past 20, not quite 30. Let's say it's right there. There's your 23. Okay, and we are moving to the, I don't know why I'm waiting, like I'm going to wait for you to say it because you're watching a recording, but you're waiting for the right. So, Winky Robot's counting to the right, and we're counting 31 steps. So we know we're going to the right, and we know that it's going to be enough jumps to get past the 0. All right, so we know the answer is definitely going to be positive. Well, that's something we didn't have a second ago. So how much further past 0 will it be? Well, I mean, there's 31 jumps involved. We need to use up 23 of them to get to the 0. What is the answer? 8. 8. Right? We use up 23 of the 31 jumps getting to the 0, meaning that there's 8 left. A little bit of subtraction and a little bit of borrowing. I know not all of you need to do the borrowing, but I like doing the borrowing because it's fun. The answer is positive 8. And all we're really doing is visualizing what we think is happening here with the Winky Robot or Wakey Robot or Sleepy Robot as our guide.